Hello friends, I welcome you in lecture number 12 on binomial distribution. In this lecture we will discuss one question on binomial distribution which was asked in GTU Summer 2025 examination. The question is, does there exist a binomial distribution for which variance is greater than mean? So before answering this question, we just recall the formulas for mean and variance of a binomial distribution. So we know that if we have a binomial distribution in which n is the number of trials and p is the probability of success, then mean is given by mu equal to product of n and p, and variance is given by sigma square equal to n into p into 1 minus p, or we can write variance as np into q, where q equal to 1 minus p. We know that p is the probability of success and therefore 1 minus p equal to q is nothing but probability of failure. So these are the formulas for mean and variance of binomial distribution. Now here we want to answer this question, that whether there exists any binomial distribution for which variance, that is sigma square, is greater than mu, that is mean. So we will answer this question by the method of contradiction. We start by assuming that suppose there exists a binomial distribution for which variance is greater than mean. So first we assume that there exists a binomial distribution for which variance is greater than mean. We know that variance is denoted by sigma square and mean is denoted by mu. Therefore, we know that now variance of binomial distribution is n into p into q, that is greater than mean of binomial distribution, which is n into p, where this q is nothing but 1 minus probability of success or probability of failure. Now we know that this n is always greater than 0, it is number of trials. P is also probability of success, that also we consider as positive. Therefore n into p is greater than 0. Therefore I can transfer this n into p, which is positive real number, on the right hand side. So I will have q is greater than n into p divided by n into p. So we can divide by a real number if it is positive. Therefore we have written that n into p is greater than 0. Therefore we can write that, from this we can write that q is greater than n into p divided by n into p. Now this is positive real number, therefore this we can write as 1. N into p divided by n into p is 1, because this is non-zero real number. So what we obtain, that q is greater than 1. But what is q? Q is nothing but 1 minus p, or probability of failure. And we know that value of probability is always in between 0 and 1, and here we find that probability of failure is greater than 1. So this is not correct. So what we have a contradiction. And why we obtain this contradiction? Because we assume that there exists a binomial distribution for which variance is greater than mean. So if we assume this, that variance is greater than mu for some binomial distribution, then we arrive at the contradiction. Q greater than 1 is a contradiction to the fact that probability is always in between 0 and 1. This means our assumption is wrong. Therefore we have to write systematically, our assumption is wrong, and our assumption is that there exists a binomial distribution for which variance is greater than mean, and that assumption is wrong. That means there does not exist a binomial distribution, there does not exist a binomial distribution for which variance is greater than mean. So this is simple question, and to answer this question you must be familiar with the formulas of mean and variance of binomial distribution. And we have answered this question using the method of contradiction. They have asked that whether there exists a binomial distribution for which variance is greater than mean. So we first assume that suppose there exists a binomial distribution for which variance is greater than mean, and this assumption sends us to a contradiction to the fact that probability is always in between 0 and 1, and therefore our assumption is wrong. That means there does not exist a binomial distribution for which variance is greater than mean. So sometimes they ask this type of theoretical questions also. This was asked in last GTU Summer 2025 exam. So this is all about this session. I hope you like it. Thanks for watching.